given a couple of functions, and first up we're asked to find f of minus 3. Now all this means is that we replace this x by minus 3, and hence this x by minus 3. It's going to be 12 over minus 3 plus 1. That ends up being 12 over minus 2, which becomes minus 6, and we're there. Of course, you can put all of that in your calculator if you want. Just use the fraction button. Just make sure you can do it without your calculator. You could even argue it's quicker without. There we go, minus 6. Right, f of g of 1. So I'm going to now find g of 1 first. And it's going to work in the same sort of way. I'm just replacing x now by 1. So it'd be 5 minus 3 times 1, or just 5 minus 3, which is 2. And therefore, f of g of 1 is, actually you can put brackets around it here. We put 1 into g, we get our output of 2, and then we put that into f. So it actually becomes f of 2. And then we're back to doing what we were doing in part A, really. But instead of minus 3, we're putting 2 in. So 12 over 3, we're going to get 4. We're then asked to find the inverse of g when we put 4 in. Okay, now you could find the inverse of g in terms of x and then substitute 4 in, which I will go through in a minute. Actually, I think I'm going to do that. No, I'm going to go through a quicker way first, because I don't want you to like see it and think, right, no, let's do it like this. The quickest way is actually to not find the inverse, but to use the original function. For example, I know when I put 1 in, if I do g of 1, then I get 2, because that's what we did in part B. It actually follows then that the inverse of g, when we put 2 in, will give us 1, because g and its inverse are doing opposite things. G takes 1 onto 2, inverse takes 2 back to 1. So if I wanted to find out the inverse of 2 without actually, like, if I didn't know it was equal to 1, then what I'd actually be doing is trying to find the input when I put it into my original function. Because remember, 2 was the output of g of x. So I could set my original function equal to 2 and solve it, and I will get 1 back. I should just rearrange. 3x would equal 3, x would equal 1. And I can do exactly the same thing here. So I can just solve 5 minus 3x equals 4. I'm trying to work out the output of my inverse function. This is the same as my input for my original function. So what is my value of x here? So rearrange, we're going to get 3x equals 1, x is equal to a third. Let me give you one other way of explaining it. Let's say I've got the inverse g of 4, and I'm going to set it equal to my answer, a. Then I could apply g to both sides. Now, g applied to the inverse actually just cancels out. And so I'm actually left with g of a equal to 4. That is what I need to solve to find my value of a. And that is again setting 5 minus, or 3a equal to 4 and solving. Let me just convince you one last way. We're actually going to find the inverse, and you'll see kind of how it's working for this. What is this? So we would let y equal 5 minus 3x. X is the input, y is the output. And then we would make x the subject. So we'd get 3x equals 5 minus y by rearranging. Then x is 5 minus y over 3. Then we're basically there. That takes us from the output back to the input. And then g minus 1, I then replace x by, would equal 5 minus x over 3. We could then put 4 in. Look what happens. You get 1 over 3. Remember, when we put 4 in, we've actually put it in here, which was here, and actually, which was here. So again, you could just set it equal to 4 at this point if you kind of realize it. So I'm just trying to show you, it's actually 3 sort of different ways to show you that you can just set the original function equal to 4 and solve it to do this question really quickly. Hopefully that makes sense. If in any doubt, I would say find the inverse function and then put in 4, as long as you're happy rearranging it and everything, because I do think the methods I'm talking about here are quite subtle. Well done.